In this video, we are going to see non-contiguous memory allocation techniques, which is paging. Here, non-contiguous memory allocation system supports paging and segmentation. There are two ways. Paging and segmentation are the two ways which allow a process's physical address space to be non-contiguous. It has the advantage of reducing memory wastage, but it increases the overheads due to the address translation. It slows the execution of the memory because time is consumed in address translation. In non-contiguous allocation, operating system needs to maintain the table which is called page table for each processes, which contains the base address of the each block which is acquired by the process in memory space. So the logical address space is divided as page here. In non-contiguous memory allocation, different parts of a process is allocated different places in main memory. Spanning is allowed, which is not possible in other techniques like dynamic or static contiguous memory allocation. That's why paging is needed to ensure effective memory allocation. And paging is done to remove external fragmentation. But still, paging suffer from internal fragmentation. Here, a process can be spanned across different spaces in main memory in non-consecutive manner. Suppose a process P of size 4 kilobyte, consider main memory having two empty slots each of size 2 kilobyte. Hence, total free space is free space is 4 kilobyte. In contiguous memory allocation, process P cannot be accommodated as spanning is not allowed. And in contiguous allocation, space in memory should be allocated to whole process. If not, then that space remains unallocated. But in non-contiguous allocation, process can be divided into different parts and hence filling the space in main memory. In this example, process P can be divided into two parts of equal size, which is 2 kilobytes. Hence, one part of the process P can be allocated to first 2 kilobyte space of main memory, and other part of process P uh, can be allocated to second 2 kilobyte space of main memory. So these are the filled spaces. As you can see, this process space is divided into pages, and the main memory, which is physical memory, divided into frames. So we can allocate the process memory needed in non-contiguous way. And but in what manner we divide a process to allocate them into main memory is very important to understand. Process is divided after analyzing the number of empty spaces and their size in main memory. Then only we divide our process. It is very time consuming process, their number as well as their size changing every time due to execution of already present process in main memory. In order to avoid this time consuming process, we divide our process in secondary memory in advance before reaching the main memory for its execution. Every process is divided into various parts of equal size called pages. We also divide our main memory into different parts of equal size called frames. So processes are divided into pages and main memory is divided into frames. And it's very important to understand that size of the page in memory, size of pages in process is equal to size of frames in memory. So both size are equal. Consider empty main memory having size of each frame 2 kilobytes and two processes P1 and P2 are 2 kilobytes each. And paging allows memory space of a process to be non-contiguous. Paging is more flexible as only pages of a process are moved. It allows more process to reside in main memory than contiguous memory allocation. So here in this video, we have seen paging in non-contiguous allocation. In next video, we will see more memory management techniques. Thank you.